In exercise 6.7, we're now going to go through the CCEA question 1. Now, part A of the question gives us a COP value of 3.5, and it then asks us to explain what is meant by a coefficient of performance. Now, inside the mark scheme, there is reference to efficiency. That's wrong, because a COP of 3.5, when transferred into percentage, as is traditionally done with efficiency, would give you 350%. Nothing can have an efficiency greater than 100%, and this is indeed incorrect physics. Now, what the COP really means of 3.5, you put in 1 unit in terms of the electrical energy for your compressor and they run the little electrical pump, and you get 3.5 units out. But that is not a representation of efficiency. Just want to make that clear. Now, in terms of what I know then for part B, we of course know that the COP does equal 3.5. Again, there's no units there. And we're also told, much like the previous question 8, the heat pump uses up 3.6 megajoules in 1 hour. And of course that represents W. And again, that is in 1 hour. And that'll be important at the end of the question. Now, much like again question 8, we are asked to work out, well, what is the heat output in this time? And so we're really asked for a value of, well, what's QH? But again, in 1 hour. And that'll be important again at the end of the question. Now, much like the previous question, we've seen that COP is quite simply QH divided by W. Well, we're looking for a value of QH, and so we're going to have to multiply both sides of the equation by W. The left hand side becomes COP multiplied by W equals Q multiplied by W divided by W. On the right hand side, of course, one number divided by itself will cancel out, and so we put a H in there. The QH is then equal to COP multiplied by W. We can now sub in the respective numbers, and that becomes 3.5 times 3.6 megajoules in 1 hour, and that becomes then 12.6 megajoules in 1 hour. But of course, it's only asking us for the exact amount of energy in 1 hour, and so we don't have to include that time interval, and so the final answer is quite simply 12.6 megajoules. And that concludes this particular question.